In our game, A Familiar Place, you find yourself stuck in the backrooms and you need to escape. We use Scanning as our physics engine. The walls have plane physics bodies and the player is a sphere physics body. This is what prevents you from running through walls. We use hierarchical modeling in many different places. Our rooms contain the lights, walls, and models within them. For our crosshair, we use a raycaster to determine whether you're looking at a model that's interactable or not. So, for example, this model is not interactable, and this one is. As you can see, an eye opens up. For our lights, we use rect area lights. This is because rect area lights look more realistic than point lights, and they're a good fit for the rectangular lights that you usually see in the back rooms. Rect area lights are fairly performance intensive, but the first level of the back rooms handles as well because of its dynamic room rendering system. At any given point, at most 2 rooms are being rendered. I'm going to break the illusion a bit here by showing you the map view. So you can see right now only 1 is rendered. But if we walk close to the exit of a room, like here, you can see the next room is rendered. So every room has at most 2 or 3 rect area lights. So at most we would be rendering 6. And this is what gives us fairly decent performance. But the room rendering system serves another purpose. When you walk close to the exit of a room, the system selects a random room and a random entrance to connect to the exit of this room. So let me just show you that. See here, there's 1 room. And now there's a different one. To get this to work, we define specific zones called render zones. When you walk into a render zone, the next room renders at the exit that corresponds to the render zone. The system chooses a random room and an entrance of that room, then rotates it accordingly and positions it so that the entrances of the rooms line up exactly. The reason we implemented this was to make the player feel lost and disorientated. So here you can see a visual of what the render zones look like. They're all at the exits of a room, like that. Most of the models in this level we found on Sketchfab and then edited in Blender. This marker originally came in a big set, so we isolated the black marker and joined the mesh, which was originally separated into many tiny pieces. Let's find the main room. Here we go. For the notes, we edited text in Canva, exported that as a transparent PNG, and then imported that into Blender as an image mesh. To then get the text on the note, you subdivide the image mesh, apply a shrink wrap modifier to it, and then project it onto the note. You can write on this whiteboard, and to be able to write on it, we use a canvas which the user types on, which is then applied as a texture that is mapped onto the material of the board component of this whiteboard. And the solution to this puzzle is 213. Congrats if you found that. Then you find the slide and you can move on.
Hey, this is Nathan, and I'll be speaking on the work I did with regards to the signing room here, the playground room here, and on behalf of Justin and the room and puzzle associated with it that he did over here. The sign-in room is set to be the transition between this level and the next via this door, which is currently locked, which is indicated by that sound. These two objects here, which are currently unhappy faces, change when the corresponding room's puzzle has been solved. So when this room's puzzle is solved, this will change into a happy face. When this room's puzzle is solved, this will change into a happy face. And once both are changed into happy faces, the door will become unlocked and allow the transition to the next level. The puzzle in the playground has a variety of hints provided to solve it, such as these images on the walls, as well as sounds. If an incorrect model is played, its own model sound would be played like this. Or, while a correct one would be played like this. The solution to the puzzle can be found by looking at the number of figures in each of the pictures. See, this is one image or person here, means he's the first one you click. 2 people here, second person, 3 people here, third, and fourth is the last one. So far I've clicked the first one, which is the slide, and then I'll click the trampoline as a second, merry-go-round as a third, and swings as a fourth. And then once all of them have been selected and the puzzle is completed, no matter what objects you play, they'll play their own sounds, even if the object or puzzle has been solved. Now, if you come look into the signing room, the associated object I was talking about earlier that was an unhappy face has now become a green smiley face. Justin's puzzle room here has these objects, which when once interacted with, display a number. These numbers associate to the code which you would input into this corresponding keypad. The way to find out the code is to look at the order on which the words appear on this projector or screen over here. See, play would represent the doll. Laugh represent the clown. Stay would represent the chair, and scream would represent the face. So if we go in that order, we would see doll is 4, laugh, which would represent the clown, is 7, stay, which is the disc, is 0, and scream, which is the face, is 5. So if we input that code into this thing, you see it now says access granted, and it will kick you out. Now the corresponding unhappy face is now a smiley face. Now, we can interact with the door again and it'll play a different sound, and will allow the transition to the next room, which is the pool room.
Hello, my name is Josh Rippleman. I'll be doing the devlog section for the pool rooms in Backrooms Escape, namely on behalf of both Dearbolt and I. As you can see, for ours we took inspiration from the concept of the pool rooms, from the linear spaces aspects that take place online. First room obviously being the normal back rooms, second one being the playrooms. The idea is we wanted to implement a lighting puzzle, especially considering how much we've learned about the lighting elements inside of CGV. So we wanted to try and implement something more based on light and the mixing of light, and we came up with this idea for the idea where you have to mix these lights on different sensors. So as you can see what I just did over there, I placed a red light on the red sensor, which causes it to open in where it originally starts, pointing at a magenta sensor to open the magenta door. But you see a blue light doesn't actually allow for that to be directly opened. So what we have to do is instead take both the blue and the red lights to that location, and when doing that, you can actually see that it will open. Some of the cool things that we had to really overcome while attempting to solve this is when you shine a light, you're not facing away from it, and that it's actually like pointing it and within range. So as I get close enough, you'll see that since I've now mixed the blue and red to make magenta that it matches, it will open the green light. Again, the reason we wanted to choose a lighting puzzle for the pool rooms is because of the white background. It allows it to more easily see the lights interacting with each other and know exactly what colors you're actually mixing. It was quite challenging to try and overcome like the sensors actually interacting and reading the correct properties with the additive colors and making sure everything works 100%. It was a challenge, but it was quite fun to overcome. As you can see at the start, over here you will get yellow with those two, and over at the start over here you'll see we came through the door that was from the playrooms. It's quite a simple puzzle once you get the main concept, but we wanted to not give any hints to try and let the environment really tell the story and give a general understanding. But as you can see, when we finish and I bring this over here, you will notice that the door will open and we have escaped for now. And after a couple seconds, it should refresh us back to the main page.